In this video, we'll talk about what is significant figures. So significant figures essentially just tells us how precise a measurement is, how precise our numbers are. Okay, what does that mean? To understand that, you need to understand that there are two different types of numbers. One is called an exact number, the other one is called a measured number or a measurement. What are the measurements or measured numbers? Measured numbers are essentially something that we measure experimentally by using certain tools. For instance, if I want to measure the height of an object, I need to use a ruler to measure the height. So I need a measuring device to get that measured number. What if I'm trying to measure the weight of an object? That has to be done using a scale, weighing scale or a measurement scale, right? So whenever we are using a measuring device, a measuring tool, an instrument to get to a number, that is called a measured number or a measured value. Whereas an exact number, let's say an exact number is just a defined number. Okay, for instance, when we say, let's say 1 kilogram is equal to 1000 grams. That is already known. That is a fact, right? So these numbers right here are exact numbers. They don't have any significant figures in them. The exact numbers don't have any significance. Okay. The other kind of exact number would be, let's say you're counting something. If you're just getting to a number by counting something, for instance, I have like 10 pennies in my pocket. How did I get to that number 10? That 10 number was obtained by counting those pennies. So that is not a measurement. I did not use a tool to get to that number. That is just a simple counting that I did. Okay, so that is an exact number. Another thing is, let's say I have like, when I say I have like a dozen of bananas. What is a dozen? A dozen is always equal to 12 units, right? So that's a definition that is already known. It's not a measurement that we are making. If I say I have a dozen bananas, that just means I have 12 bananas. I did not do a measurement. I simply counted it, or I simply went by the definition. So if you're going by definitions, or if you're just taking an exact number by counting it, that is an exact number. Okay, so that is the difference between exact number and a measurement. A measured number is always done by measuring an object using a measuring tool or an instrument or a measurement device. Okay, so for instance, I ask you, this is a particular line or a stick provided to you. Can you tell me what is the length of the stick based on this ruler? So if I ask you that question, some people might say, okay, this is definitely longer. Let's say this ruler gives you measurement in meters. Okay, this is a meter scale. So some people might say, oh, this stick is, I don't know, around 4.8. Let me actually write it up here. Some people might say, oh, this stick is probably 4.8 meters. Okay, somebody might say, oh no, I'm looking at it from a different angle, or based on my measurement, this is like 4.6. Somebody might say, okay, this is 4.7 meters. Okay, so currently, based on my measurement, I see this right here. For how would you take the measurement? I'm sure that this, or I'm certain that this stick is greater than 4, right? So it is 4 point something. I'm certain of that. What am I not certain of? How much? 4 point how much, right? So I'm just gonna eyeball this. Okay, this is 4.5. Then I have like 6, 7, and 6, 7, and okay, this is 8. Okay, so I'm gonna go with 4.8 meters. Now, let me just switch this question and let me ask you, okay, I give you this ruler now. Can you tell me what is the measurement of length for this particular stick using ruler number B? So now what you can do, you would say that, oh wow, this stick has like more graduations, right? So I can be sure of what I'm saying. I can be more precise with my measurement. So now based on this stick, if I'm taking the measurement, this, oops, this lies somewhere right here in between this. Okay, so now what am I sure of? I am sure that this stick, so if this is 4, you can see there are 10 more smaller lines between 4 and 5. So this midpoint right here is 4.5. This is 6, 4.7, 4.8. So now I'm sure that this stick is 4.8 meters. Now 4.8 how much? I am not sure, but I can eyeball it. So if this is 4.8, this is this is 4.8, this is 4.9. I am like somewhere between 4.8, I don't know, 7 meters. Okay, so now you can see right here, this ruler above only gave us 4.8 meters. The ruler below told us that the stick is 4.87 meters. So which ruler right here is more precise? The bottom one, right? So this is exactly what sig figs tell you. The more number of sig figs means the measurement that you made is more precise. So significant figures tells us how precise your measurement is. And what is important here, you can only, the significant figures are only considered significant in measured values, meaning I am taking this measurement using a measurement device or an instrument or a tool. That's why I can talk about sig figs. If it's an exact number, it doesn't matter. But if it's a measurement and I'm using a tool, sig figs are important. Now, how can you decide how many sig figs a measurement tool will give you? You always, whenever you're writing a number, whenever you're making a measurement, you have to consider what is a certain number. You always write down the certain digits that you're certain of using your tool. For instance, when I was using this bottom tool, I'm certain that my value is between 4.8 and 4.9. So I'm certainly sure that it is above 4.8, right? Now, whenever you write your certain digits, then you add one more extra digit which is estimated, which you're not sure of or which you are uncertain of. And that digit right here, based on this ruler, let's say I give it 4.87. So this is the number of sig figs that this particular measurement device will give you. That's how you decide how many sig figs can a measurement device give you. Okay, you cannot just simply make up any number of decimal places. Okay, you cannot simply say that, oh wow, this stick, based on the bottom ruler, I would say it's 4.8764. Okay, you cannot make that measurement up. This is science. Okay, you cannot just make things up. So why am I saying this is 4.87? Because I'm certain that this is more than 4.8. I am certain that this is 4.8. You write your certain digits and then you add one more extra digit, which is your uncertain digit, or which you're not confident about, or which is your estimated digit. Okay, and that would make your correct number of significant figures that that particular device can give you. All right. So for instance, let's say if we are taking measurement from this particular thermometer. Okay, so what is the reading of this thermometer? So if you're taking a reading, you can see right here, this value lies right somewhere in here. It is definitely, this is 100, right? And this is 110. Okay, so if this is 100, this is 105, the midpoint between 100 and 110. So this is 101, 102, 103, 104, 105. So I am certain that this is 103, right? So I'm certain right here that this is 103, and this is greater than 103. 10, sorry, is it 3? 1, 2, 3. This is greater than 103. This is between 3 and 4. So I am certain. So you first write your certain digits followed by an uncertain digit. So what is my uncertain digit here? I'll write that uncertain digit. Okay, maybe this is like 103.2 degree Fahrenheit. Okay, so that is your uncertain digit, and this is the right number of digits that this particular device can give you. Okay, so let's say if in this scale, let's say, okay, so see right here, this is giving you 103.4. I came up with 103. Oops, I came up with 103.2, so that is okay. That is why you include that uncertain digit, and you're telling me that, okay, I am sure this is 103. I am not sure if the last digit is 4 or 2 or 3 or 5 or 1. I'm not sure of that. Okay, so you're giving me that information by giving me this measurement. I already know that, okay, this number 4 that I'm seeing at the end might not be very certain number. Okay, all right. So now you understand how, when you're taking a measurement, how do you decide how many sig figs should be present in a number? You have certain digits followed by one uncertain or one estimated digit. If a measured value is already given to you, how do you decide how many sig figs are present in there? We use these 4 rules for that. Okay, so you have to memorize these rules, remember these rules, and that would help you count how many sig figs are present in a measured value. For instance, the first rule tells you that all non-zero digits are significant. Very simple. If it's a non-zero digit, it is significant. For instance, if I have this number right here, 123.4, 123.7, how many sig figs does this have? You basically just count all the digits that are significant, and that would give you the number of sig figs. So 1 is significant, 2, 3.7, which means 1, 2, 3, 4. I have 4 non-zero digits, and all non-zero digits are significant. So number of sig figs is 4. How about question 2? Rule number 2. Rule number 2 states that all the zeros that are present between the non-zero digits are significant. So for instance, if I have number 1207, how many sig figs does this have? Even if it's a zero in between, it is still significant. Why? Because it is in between two non-zero digits. So I have 1, 2, 3, 4. I have 4 sig figs in this number. Simply take it as I give you $1,207, right? So you cannot just simply ignore this. You cannot say that you have $127, right? So if you can't ignore the zero in between, that means it's significant. Okay. The second example you see right here, it is 120.007. So all the zeros here in between will be significant. Why? Because they are present between two non-zero digits. So how many sig figs does this have? You simply count the total digits that are significant, which is 1, 2, 3, 4, 5, 6. So this has total number of 6 sig figs. The next rule says that all the zeros at the left of the number are not significant. If the number that we're talking about here, the number that we're talking about is the non-zero digit. So all the zeros on the left of a non-zero digit are not significant. Meaning if I write the number 0.00032, then these zeros that are present on the left side of this number 3, the first non-zero digit, these are not significant. Okay, so how many sig figs does this have? This zero, these zeros are not significant for us. What is significant? This 3 and 2. So this has essentially 2 sig figs. Okay, so all the zeros that are on the left side of a non-zero number are not significant. Remember that. Okay. For instance, if the question is how many sig figs does this number have? This is the first significant number that is present. All the zeros on the left side of this is non-significant. So this we don't count, this we don't count. What are we counting? Just 3, which means this has only 1 sig fig. And the last rule also applies to zeros. So when the zeros are at the right of the number, okay, so this is when the zeros were on the left of a number. Now what happens if the zeros are on the right of the number? Now this has 2 different scenarios. If there is no decimal place, then the zeros are not significant. But if there is a decimal place, all the zeros on the right of the number are also significant. For instance, if I take this example 300, okay, so where are the zeros located? First thing I know, that's 3 significant. Why? Because it's a non-zero number. Okay. Next, I have to decide, are these zeros significant? There is no number right here, right? So that doesn't make it significant. Second thing, there is no decimal place. These are on the right side. Remember, if these zeros are on the right side, there has to be a decimal place at the end. If there is no decimal place, none of these zeros are significant, which means this only has 1 sig fig. The next example is 25400. Here again, where are the zeros located? I know this is 1 sig fig. This is also significant. This is also significant, right? So I have 3 sig figs as of now. How about these zeros? These are on the right side. If they're on right side, you have to look for a decimal. Is there a decimal place right here? No, which means these zeros are not significant. So the only number of sig figs present here is 3. let's pick this example right here. Okay, so what do we have? We have 6, which is of course a non-zero number, so significant. Then how about these zeros? These zeros are on the right side, but there is a decimal place. So if there is a decimal place, every zero is significant, each and every zero. So which means this has 3 sig figs. How about this number right here? How do we know how many sig figs does this have? So these zeros that we see up front, these are on the left side, right? So all these zeros, the rule number 3 tells us that all zeros on the left of the number are not significant, which means none of this is significant to us, right? What is significant? 4. This is significant. 3 is significant. How about these zeros? These zeros at the end, you see here, there was a decimal place right here. The decimal doesn't have to be always on the right side. There is a decimal right here. If the number has a decimal place, then all these zeros in that number would be significant, except that it is starting from a non-zero digit. Okay, so all these zeros will be significant, which means this would be 5 sig figs. Okay, the 4 zeros at the left of the number do not count, but the 2 zeros on the right side do count. So if there is a decimal, the zeros are significant as long as they are on the right side of the number. So these are all the rules. If you can remember these rules, you simply practice a bunch of questions to count how many sig figs are present, and that should give you the right answer. Okay, so let's say these are again the rules given to you again with some more examples. And remember, whenever we have exact number, we do not count sig figs. If you're counting individual objects, doesn't matter. Sig figs are not important. If you're getting the number given to you by definition, which means if I tell you that, okay, 1 dozen is 12 units, that is a definition that I'm giving you, which means it's not significant. If I tell you that, okay, 1 kilogram is 1000 grams, I am giving you this definition. So in this case, number of sig figs does not matter. Number of sig figs are only important when you're making a measure. So here are a bunch of questions that you can try to tell and pick how many sig figs are present in a number. For instance, let's try a couple questions. So if I try this first question, which zeros are significant? These zeros are lying on the left of the number, so they are not significant, right? So how many sig figs does this have? This 3 right here is significant, 5 right here is significant. So I have 2 sig figs in this. How many sig figs are present in this number right here? What are the rules? The number, all the non-zero numbers are significant, which means this is significant, this 8 is significant. How about zeros? If the 0 lies within the non-zero numbers, then that is significant. If it is between, right? And this 0 right here is on the right side. If it is on the right side and there is a decimal, then this is also significant. So this has 4 sig figs. How about this? 2, 3, 7, 1, all non-zero digits are always significant, so this is also 4. How about this? Whenever you see a scientific notation, how can you figure out how many sig figs? You always look at the decimal part. So ignore the exponent, just count the number of sig figs in the decimal part. And the same rules that we saw apply to this as well. This is a standard number, right? So in this case, just count the number of sig figs following all the rules that we just saw. So each rule applies here. So in this case, it's all non-zero, meaning everything is significant, meaning this is 3 sig figs. How about this? 1 dozen is 12. This number of sig figs does not matter, right? Because this is an exact number. This is an exact calculation that is given to us. So we do not care about number of sig figs here. How about this right here? 100,000. This, in this case, 1 is significant. How about the zeros? The zeros lie on the right side. Is there a decimal? There is no decimal, so none of these are significant, which means this only has 1 sig fig. So there are tons of questions provided to you, more examples. You can practice those, but follow the same rules. Okay. Now let's see what rules apply when you are doing an actual calculation. Let's say you're doing multiplication, division, addition, subtraction. What happens to sig figs? Okay, whenever you're multiplying or dividing the measurements with significant figures, the result has the same number of significant figures as the measurement with the fewest number of sig figs. Okay, what does that mean? So if you're multiplying, let's say, two numbers, you count the number of sig figs in both the numbers. Whichever one has the least number of sig figs, that is the number of sig figs that your final answer should contain. For instance, if we are multiplying this, so what you will do, if I ask you this question, what is the final answer for this? Can you multiply these three numbers? What do? You take your calculator, you plug in 5.02 times 89,665 times 0.10, and your calculator would give you this number right here, 45.0118. But that is not your final answer. Your final answer would be based on the number of sig figs. So how do we decide how many sig figs? If it's a multiplication or division question, remember that. This rule applies when it's multiplication or division. Okay, so how many sig figs are present in this number? I see 1, 2, 3. All three are significant, so this has 3 sig figs. Okay, how about this number? This is 1, 2, 3, 4, 5. All non-zero digits, so all significant, so this has 5 sig figs. Okay, how about this? This number, this 0 is on the left, so it's not significant. This 1 is significant, and this 0 is also significant because it's on the right side, and there is a decimal in this number, which means this has 2 sig figs. So which one of these three has the least number of sig figs? This right here. So your final answer should have the number of sig figs equal to the least measurement whenever you're doing multiplication and division. Remember that. Okay, this rule only applies when you're doing multiplication or division. So in this case, your final answer should only have 2 sig figs. So in this case, 1, 2. So my answer has to end in these 2 sig figs. This is 45. Now, how did I decide this is 45? The number that is followed by that, the number that is followed by a correct number of sig figs, if that number, for instance, right here it is 0, if this number that is following is greater or equal to 5, if this number is equal to or greater than 5, then you round the number up. Okay, and if this number is less than 5, you leave the number as it is. Leave number as is. Okay, what does that mean? If this is 45.0, the answer is 45. This number, following number is 0, which is less than 5, so I leave the number as it is. For instance, I give you a question, and let's say the answer came out to be 45.618. Okay, so I know my final answer should have 2 sig figs, so it has to end right here between these two numbers. What is the following digit? The following digit is 6, and 6 is greater than 5, which means I have to round the number up. So my final answer in this case would be 46 and not 45. Okay, that is one more rule of rounding up or rounding down the number. You only round the number up if your following digit is greater than or equal to 5. Okay. Let's try one more question right here. So if I give you this question, 5.892 divided by 6.10, what would be your final answer? If you plug this into calculator, it would give you 0.96590. But now how many sig figs should I leave? So this number right here has how many sig figs? 1, 2, 3, 4. This has 4 sig figs. This has 1, 2, 3. This 0 is also counted. Why? Because this is on the right and this is after a decimal. So this is, and there is a decimal. Doesn't matter if it's after or before decimal, but there is a decimal place in the number. So this is 3 sig figs. This is a division question, so we go by the least number of sig figs, which is 3. So my final answer should end at 3 sig figs. 3 sig figs would be 0. We don't count this towards sig figs. Why? Because this is on the left side of the number, right? So we start with the number, which is 1, 2, 3. The number after this number of sig figs is 9. So the digit following the correct number of sig figs is 9, which is greater than 5, which means your final answer would be rounded up to 966. The final number would be rounded up. You basically just add 1 to the last significant number that you see. Okay, so that is what is rounding up and rounding down means. Now, what happens if the question is talking about addition and subtraction? The rules are a bit different when we talk about addition and subtraction. When we are adding and subtracting two numbers, remember, we don't look at the number of sig figs in those two numbers. We look at the number of decimal places in those two measured values, and we go with the least number of decimal places out of the measured values. Okay? So the rule states, when adding or subtracting the measurements with significant figures, the result has the same number of decimal places as the measurement with the fewest number of decimal places. Okay, so here we don't look at number of sig figs, we look at the number of decimal places. This is true when we are doing addition and subtraction. So let's look at a couple examples again. So if we are doing this addition, 5.74 plus 0.823 plus 2.651, you plug this into your calculator, which would give you 9.214. Now, how do we know what is the correct number of sig figs in our final answer? You look at number of decimal places in each of these numbers. How many decimal places does this have? This has 2 decimal places. This has 3 decimal places. This has 3 decimal places, and the rule tells us we go by the fewest number of decimal places, which is this. So our final answer should have 2 decimal places, which is 1 and 2. So it has to end right here. So if it ends right here, what's the next digit? The next digit is 4, which is less than 5, which means you leave the number as it is. So your final answer is 9.21 with 2 decimal places. Okay. Let's try another question. So for instance, right here, if I give you a question of 4.8 minus 3.965, what's your final answer? So you plug this into your calculator, it would give you 0.835. Now, what is the right number of sig figs that we write? This number, this is again a subtraction question. That's the most important thing. If it is addition subtraction, you do decimal places. So in this case, we have 1 decimal place. Here we have 3 decimal places. Which one is fewer? This is fewer. So our final answer should only have 1 decimal place, which means it should end right here. So 0.8, and the following digit is 3, which is less than 5. So we leave the number as it is. So the final answer is 0.8. Okay. So now you guys can try a bunch of questions using the same examples. Some more examples. Okay, same rules. Now, couple more things here. Whenever we are doing some more other questions are given to us, some other math questions are given to us. Now, if something like this is given to us, what is the rule? The first rule is whenever you see parentheses, you first solve the parentheses. That is the first rule. Okay. The second rule is you do not round the number up or down until you get to your final answer. Okay. You do not put the final number of sig figs until you get to the final answer. What do I mean by that? So if you are trying to solve this question, what would it give you? So first thing we do is, you see in the question there is parentheses. So the first thing I have to do is I have to solve this parentheses. So the first thing I'll plug into my calculator is this. So if you plug into your calculator 5.67 minus 2.3, that would give you, oh, that would give you 3.37. Okay. Now, how many sig figs should this have if I'm just solving the parentheses? If you were doing this separately, this has, the first number has, this is a subtraction question, so we are going to go by decimal places. The first number has 2 decimal places, right? The second number has 1 decimal place. So what should our final answer have? Our final answer should have the fewest number, which is 1. So it should end right here. Okay. So if you were doing this separately, your final answer would be 3.4. Why 4? Because the following digit is 7, which is greater than 7, so you round 5, so you round the number up. But in this case, we do not round the number yet. Okay? What we do is we go to the next step, which is 3.489 times this. Now, what you have to remember here is remember the number of suffix and right here. Okay? Now you plug this into your calculator, okay, and you solve for your final answer. Now if you plug this into your calculator would give you 11.75793. Now what is the right number of sig here? Now you decide what is the final number of sig. So this is a multiplication question now. So we are going to go by the number of sig. This digit right here has how many sig? 1, 2, 3, 4. This is 4 sig. How about this? Remember when we were doing this question, we said the number has to end right here, which is 3.3. So what is the correct number of sig here? You will count the correct number of sig where you made the mark, which is this would have this and this. So it would have only 2 sig. The 7 here is not significant. Okay, how do we know that? We know that because of the parentheses rules, because of the rule of number of sig with addition and subtraction. We already did that for our previous part. Only thing we do not do, we do not round the number up or down until we get to the final answer. So now this final answer should have how many suffix? Only 2 suffix, which is the least number of suffix. So 2 suffix means 1 and 2. So this has to end right here. Now what is the following digit? Is 7, which is greater than 5, which means we have to round the number up, so it will turn into 12. Okay, so make sure you're following these rules and you do not, whatever is your answer in between, which is called the intermediate answer, you do not evaluate the suffix in the intermediate answer. Okay, you only count what is the final number of suffix, but you do not round it up or round it down. You just figure out, okay, what is the number of suffix that should be in the intermediate answer, and just continue. Okay, let's try one more example question here. So let's say I'm given this question, which is solve for this 0.2465 times 25 divided by 1.78. Okay, whenever you see numbers written like this in parentheses and there's no sign in between parentheses, which means right here between these two parentheses it doesn't say if it's addition, subtraction, multiplication, division, you don't see any symbol, that in default that means this is multiplication. Okay, whenever there's no symbol or there's like a dot in between, that is just like normal mathematical representation that these two numbers are to be multiplied together. Okay, division can be written like this, division can also be written like this. So I could have like what is 4 divided by 2, I could write as 4 divided by 2. So those two are division. Multiplication essentially means you could write like this, or you could put a dot, or you simply just put like two parentheses, which means if there's nothing written in between, that means this is multiplication. And addition and subtraction, you would always see symbol like this or like this. Okay, anyways, moving on. So if you plug this into your calculator, that would give you a really long number, which is 3.462078. Keep going, something, right? But now, what is our final answer? That would depend on number of suffix. So remember, this is multiplication up top and division right here. So this is a multiplication and division question, which means I can go by the least number of suffix. So how many suffix does this first measurement have? It has 1, 2, 3, 4, only 4 suffix. The 0 up front on the left is not counted. This second number or second measured value right here has only 2 suffix. Both 2 and 5 are significant. Why? Because they are non-zero. All non-zero digits are significant. Same here, all non-zero digits are significant, so this has 3 suffix. What is our final answer consist of? It consists of the least number of suffix, which is 2. So the answer should end right here, 3.4. But what is my final answer? The following digit, always look at the following digit. The following digit is 6, which is greater than 7, which means my final answer would be 3.5. And if this was an addition or subtraction question, you would go by the least number of sig figs. So let's say if I give you this question right here, in the form it is 0.2465 plus 25. Your final answer would be 25.46, oh sorry, 25.2465, right? But that's not our final answer. That is the addition answer. What is the final answer? This is the addition question. So how many sig figs do I want? Whenever it's addition or subtraction, you look at decimal places. So this right here has 4 decimal places. The second number has 0 decimal places. So which one has the least decimal place, which is 0, which means my answer should have no decimal places, 0 decimal places. What is the following digit? The following digit is 2, which is less than 5, which means I do not round it up, I leave it as it is. So my final answer would be here, 25. So these are a couple examples that you could find a lot of questions in practice worksheet. Just practice those questions and the questions would look very similar to it. And this is all about sig figs and how do you count number of sig figs.